Hello, and welcome to Semester 1 of High School Geometry in 5 minutes. This is a plane and this is a point. By drawing a never-ending arrow out from a point, we create a ray. A line segment is created by connecting 2 points. By drawing 2 rays out of a point, we create an angle. This specific angle is acute, as it measures less than 90 degrees. An angle that measures exactly 90 degrees is a right angle. This specific angle is obtuse as it measures more than 90 degrees. An angle that measures exactly 180 degrees is straight. There is only one possible line between 2 points. This is called the point-line plane postulate. By drawing 2 lines in a way that a third line is formed, we know that the sum of the lengths 2 smaller lines is the length of the bigger line. This is known as the segment addition postulate. By drawing 2 angles in a way that each angle shares one ray with the other, we know that the sum of the measure's smaller angles is the measure of the larger angle. This is known as the angle addition postulate. 2 lines that run side by side and maintain the same distance between themselves are known to be parallel. If a line that intersects a line creates a 90-degree angle while doing so, these lines are known to be perpendicular. A line that intersects a system of lines is a transversal. The angles in blue are equal by the alternate interior angles theorem. The same goes with the angles in purple. The angles on the right of the transversal are supplementary, meaning that they add up to 180 degrees. The angles on the left of the transversal are also supplementary. This is a triangle. A triangle where none of the sides are equal is scalene. A triangle where 2 of the sides are equal is isosceles. A triangle where all of the sides are equal is equilateral. Let's draw a triangle with side lengths 2, 2, and 6. We can physically draw out this triangle and realize that it can't exist. This is known as the triangle inequality theorem. For any triplets of side lengths x, y, and z, x plus y must be greater than z. Next up, we have triangle congruences. 2 triangles are congruent if they have 3 pairs of congruent angles and 3 pairs of congruent edges. For the following few theorems, note that the letter S means side and the letter A means angle. The SSS theorem states that if 2 triangles have 3 pairs of congruent sides, then they are congruent. SAS states that if 2 triangles have a pair of congruent angles wedged between 2 pairs of congruent sides, then they are congruent. Triangle congruence can also be proved using ASA and AAS. By drawing 2 parallel transversals cutting through a pair of parallel lines, we get a parallelogram. Opposite angles in a parallelogram are equal. The same applies to opposite sides. A parallelogram where all angle measures are right is a rectangle. Opposite sides in rectangles are equal. Rectangles where all sides are equal are squares. Rectangles have a property where their diagonals are equal. Rhombus are parallelograms where all sides are equal. If the angle measure of a rhombus is right, then it is a square. A trapezoid is formed by drawing 2 non-parallel transversals through a pair of parallel lines. Keep in mind that parallel lines properties apply here, and the angles in the same color are supplementary. Next up, we have similar triangles. Similar triangles are triangles that have the same shape but different sizes. The triangles in blue are similar triangles. Similar triangles have many interesting properties. If 2 triangles are similar, the following property holds true. Similar to triangle congruence, proving triangle similarity is no easy task. For the following few theorems, note that the letter S means side and the letter A means angle. The AA theorem states that if 2 triangles have 2 pairs of congruent angles, then they are similar. The SSS theorem states that if 2 triangles have 3 pairs of similar sides, then they are similar. The SAS theorem states that if 2 triangles have a pair of congruent angles wedged between 2 pairs of similar sides, then they are similar. If we draw 2 triangles that share 2 lines and 1 point, we end up with something looking like this. The following identity must hold true in this scenario. Using triangle similarity, we can prove the geometric mean theorem. However, I will not go over it in this short overview video for the sake of time. With that, you now know the basics of the first semester of high school geometry. I would like to remind you that this is just a basic overview video, and all high school geometry courses go much more in depth than this does. Be sure to like, subscribe, and stay tuned for semester 2.